Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank you to all those of you who are attending today. We think it's going to be a very valuable discussion about the recent updates to FM Global Datasheet 8-9, and especially a very big thank you to Wes for joining us here today to talk about these updates that recently came out. So it was about a month ago. The updates are indicated in Datasheet 8-9 as the July 2020 interim revision. It's about a month ago that I received an email from FM Global letting me know that some updates had been released. I went to the website, downloaded those, and saw what really are some pretty significant updates that I think are going to be good for us all to learn about here today. What we're going to do is talk, ask some questions, talk about some of those changes. You can certainly go on to FM Global's website and download a copy of Datasheet 8-9. It's complimentary, it's free, you just have to register to do it. And in there you'll see those changes highlighted in red text. What we're going to do today is ask some questions about those, talk about some of the details of the background and what happened there, and provide some additional information that you won't get straight out of the data sheets. So again, thank you very much, Wes, for joining us here today and doing this presentation. Let me start out with something real simple, a little bit of background on yourself. Could you tell us about your role at FM Global?
Certainly, and thanks, Steve. Just to remind everybody today as to what what we're planning to do. Let me start with myself. I'm Wes Baker. For those who don't know me, I've been with FM Global for over 35 years. Now, for those not familiar with FM Global is an insurance company. And what we do is we provide our clients and protect them for property and business interruption perils. Myself, I'm a senior engineering technical specialist in what's called the Chief Engineers Group. And what that means is we're responsible for the content of the data sheets, and for me specifically related to storage, protection of general warehouses. The data sheets I tend to handle the most are those regarding Datasheet 8-9, Datasheet 8-24, which is for idle pallets. I also handle hanging garments in Datasheet 8-18. And most recently, if you've seen some releases, we also have Datasheet 8-34, which I'm responsible, which is for automatic storage and retrieval systems. In addition to the designs for general warehouses, I'm also responsible for sprinkler installation. And for storage protection, that comes in the form of Datasheet 2-0. Similar to Steve, I'm also a member of the NFPA 13, handling both the discharge and installation committees.
And FM Global, as an insurance company, can you talk about why the property loss prevention data sheets are important to FM Global?
Certainly. Let me start with what data sheets are. For FM Global data sheets, it's basically our best advice to our clients with the goal of reducing or eliminating property damage or business interruption. Now, it's important to realize our data sheets offer recommendations as opposed to requirements, since our data sheets are not code. Most codes address life safety, whereas FM Global data sheets address property conservation. Their intent is really for new construction or existing facilities that are going to be renovated. Now, one of the benefits to our clients is they incorporate the recommendations that we have in our data sheets. It gives them the opportunity to obtain their lowest insurance premium from us.
In those data sheets, we have an interim revision just released on Datasheet 8-9 in July. I think there was one about 6 months before that. How are those updates and those revisions to the data sheets developed?
When it comes to the development of FM Global data sheets, we have what we call subject matter experts, and they're the ones that are responsible for the content of the data sheet. And those are, like myself, we're within the chief engineers group. But we don't do it alone. It's a very collaborative effort within FM Global. I have a support team that involves many representatives from different departments that help us with that. Now, the content and the recommendations basically are based on three things. We first of all look at loss history, and that usually entails any loss history that might involve the last 10 to 20 years, just to see what's driving losses. We also have roughly 1,800 field engineers worldwide, and they're kind of our eyes to the world. They keep us up to date with what's trending out there. And then if we find that there are gaps in our data sheets, what we do is we really rely on our research. We do a lot of testing. In fact, we have the world's largest research campus dedicated to the study of property loss protection. It's my playground. So we use this to help drive what you find in the data sheets today.
And for those those who are out there designing buildings, installing systems in buildings, in some cases they'll be using FM Global's data sheets, particularly 8-9. In certain locations, they'll also be using NFPA 13. And we get a fair number of questions from designers and installers who are working on projects where they're using both datasheet 8-9 and NFPA 13, and sometimes the terminology is a little bit different. So we get a fair number of questions from folks trying to make it all work together, who want to make sure that they're doing everything properly. So I just want to go through a couple common questions, since we have you here today, that we receive fairly often about the data sheets. One of them is, datasheet 8-9, and it's been several years now, has eliminated terms like control mode density area, control mode specific application, especially ESFR, which is significant in the industry in NFPA 13. Why does datasheet 8-9 not use those same categories that we see in NFPA 13 for sprinklers, for storage sprinklers?
Great. Very good question. Up until 2010, we used those terms, but now we use what's called storage sprinklers. So when you look at NFPA 13 and basically all other codes around the world, they use the sprinkler listings of control mode density area, control mode specific application, and ESFR, early suppression, fast response. We, on the other hand, use the sprinkler listing of storage sprinkler for protection of storage and other high heat release type fires. Now, as you ask, why does FM Global use that listing of storage sprinkler? Well, let me show you why. Let's first start with control mode density area sprinklers, or CMDA for short. When you look at the name, it implies that its only purpose is to control fires. And when you use those types of sprinklers, what you'll find is that the demand area is typically a minimum of 2,000 square feet. In terms of hose demand, you're usually having to incorporate a 500 GPM demand for the hose. And their water supply durations are typically 120 minutes. Now, what's interesting about control mode density area sprinklers is, since it's just a density and demand area, there's no specific sprinkler listed for it, all the designs indicated have to be based on the least efficient sprinkler that's allowed for that design. So that's something that I don't think a lot of people understand. When we look at control mode specific application, or CMSA sprinklers for short, again, in the word of the listing is the word control. So again, this sprinkler listing indicates that it's intended to control fires. When you look at its design, it typically includes a minimum of 15 sprinklers in the demand area. And similar to CMDA sprinklers, the hose demand is usually 500 GPM. And in this case, the water supply duration tends to be either 90 minutes or maybe 120 minutes. So when we look at both of these sprinklers, they both indicate control. Now, they have different ways to get listed or approved for their particular category. But is there really a difference between these two sprinklers? Well, we at FM Global tested them out to find if there really was a difference. So we went ahead and had a test plan to compare these sprinklers. And what we did is we used full-scale fire testing to demonstrate the likeness or the differences. And we used a total of 16 tests. 8 we did with the CMDA sprinkler, and 8 we did with the CMSA sprinkler. And when we looked at our results, we found that basically there was no difference between them if these 5 attributes of the sprinkler are the same. So the K factor, the orientation, the nominal temperature rating, the RTI rating, and the rated sprinkler spacing, whether that's standard coverage or extended coverage, if they're the same, those sprinklers basically perform very similar. When it comes to early suppression fast response sprinklers, again, you look at the term and it has the word suppression in it. So the assumption is that these sprinklers provide suppression of a fire. Now, let me kind of differentiate between control and suppression. Control means I basically have sprinklers that go off, I pre-wet surrounding combustibles, but I'm not really getting water down through the fire plume into the fire itself to get onto any surfaces that are burning. So control basically operates in the mode of stopping that horizontal fire spread by pre-wetting the surrounding combustibles. But with suppression, the sprinklers actually get water down through that fire plume. Not only do they pre-wet surrounding combustibles, but they basically attack the fire plume on the vertical surfaces that are burning. And as a result, the fire is much smaller when the local fire services show up. And because of this type of performance, you can usually get a smaller demand area. It's typically 12 sprinklers. The hose is smaller. It's only 250 gallons as opposed to 500. And the duration of the water supply is usually 60 minutes as opposed to 90 or 120 minutes. But in the same question I asked before, is there a difference between the 2 control mode sprinklers? Is there really a difference between control mode and ESFR sprinklers? Let's take a look at some of our full-scale fire testing that we've done. So I'm going to show you a video. In this case, it's the commodity that we're going to burn is carton non-expanded Group A plastic. Our storage height is 20 feet under a 30-foot high ceiling, and our aisle width is 8 feet. So let's go ahead and see what happens during this fire. You can see we've started the clock, so the ignition has taken place. At this point now we can see the fire is growing up through the rack, and it's going to be reaching the ceiling here any second now. Our first sprinkler has operated, and based on the timing of that sprinkler and the droplets and the momentum of the fire plume and the water coming down, I mean, that we're going to actually suppress this fire. Okay, so in this case, you can see there's minimal fire damage, minimal smoke damage. And what we had was one sprinkler that opened and suppressed the fire. So what type of sprinkler was installed at ceiling level? I think many of you might be surprised to find out that it really was a control mode density area sprinkler. Okay, well, as we mentioned, those are supposed to control fires, not suppress them, but that was not the case in this situation. So let's look at another test. In this case, what we're going to show you is a commodity that's lightweight roll paper. It burns very quickly. In this case, we have a standard arrangement on end paper up to 25 feet high under a 40-foot high ceiling. Now, whatever you do, don't blink. We've started the fire, and here it comes. It's not going to take very long. We're going to have that fire up at ceiling level, causing many sprinklers to open up. And at this point, after 43 seconds, we've opened 16 sprinklers. And you can see I've got a tremendous amount of flame at the ceiling. I've got a lot of smoke being generated. In fact, it's going to block our view here in a second or two. But what we'll do is we'll fast forward the video up to around the 3-minute and 15-second mark. And as you can see, that fire is still going pretty strong. But what's happening in this fire is that those 16 sprinklers that operated are actually pre-wetting the surrounding combustibles and controlling that fire. So in this case, we opened up 16 sprinklers within 43 seconds and controlled the fire. Let me ask you again, what type of sprinkler was installed at ceiling level? Again, I think you might be surprised to find out that actually was an early suppression fast response sprinkler. So what we have found through our testing at FM Global is that we've seen control mode sprinklers that actually can suppress fires. We've seen cases where suppression mode sprinklers don't suppress, but they control fires. So we've seen cases where sprinklers really don't perform according to their assumed performance. So what we have done at FM Global by going to our listings of storage sprinkler We've indicated the use based on what the intended use is, as opposed to assumed performance. And what this does, it allows us to design our sprinklers to be based on their actual performance that they obtain during their full-scale fire testing.
So I'm going to move ahead a little bit and get into some of the updates that have happened in Datasheet 8-9 as of July 2020. And one of the significant items that we'll notice in tables 2 through 11, which are the ceiling sprinkler design criteria tables, is that there's now a lot more options where we have a 9 or a 10 sprinkler hydraulic design. And that's one that it was discussed also in the recent committee meetings on FPA 13. FM Global's gone and made some changes to Datasheet 8-9 related to that. Can you tell us about how the changes in the 9 and 10 sprinkler hydraulic designs that are new in tables 2 through 11, how those came about?
Certainly. Let me go ahead and jump ahead here.
And just to give maybe a little bit of background, just go through that. Traditionally, there's been some criteria for extended coverage sprinklers with 6 sprinkler designs, 8 sprinkler designs. Traditionally, in NFPA 13, there's been 12 sprinkler designs for standard coverage storage sprinklers as a minimum. And in FM Global Datasheet 8-9, when we look at that, it's always had, for extended coverage storage sprinklers, it's had some 6, some 8 sprinkler designs in there. And just more recently, there's been some updates to allow some 9, some 10 sprinkler designs, and those updates have become more extensive now in the July update to Datasheet 8-9. And so, it seems like there's been a look throughout the ceiling protection tables 2 through 11, to see what FM Global thinks that minimum number of design sprinklers should be. And so, the interest is, so what's the background behind the revisions to those tables 2 through 11 and how that came about?
Okay. In this case now, if we're looking at sprinkler designs for standard coverage sprinklers as low as 10, well, that was first introduced in our June 2015 edition of Datasheet 8-9. And we have added more to those today in the July 2020 edition. For standard coverage sprinklers as low as 9, those actually were introduced last January in our edition of 8-9 in table 17B. And now today, we have even more of those available to us.
Okay, and when we see those tables, there's another significant change in tables 2 through 11, or maybe some of those tables, where those tables, some of them used to go up to 45 feet for the maximum ceiling height. And if we look at the table in front of us here, for example, it stops at 40 feet. So why did that change come about?
Yeah, and when you look at our datasheet today, in previous editions of Datasheet 8-9, we had some tables that went all the way up to 45 foot high as far as the maximum ceiling heights. And there were others that stopped at 40 feet in terms of their maximum ceiling heights. So what we've done now with today's version of 8-9 is set it so that all the tables have a maximum ceiling height of 40, so they're consistent across the board. So the question comes, where do I get my ceiling designs for ceiling heights over 40 feet? Well, we have a table specifically for that. It's 17B that covers all ceiling heights now over 40 feet in height. Now, when it comes to current tables that we have, when you go back to our January 2020 edition of 8-9, the designs for some of the 45-foot high ceilings were actually removed in our July 2020 edition. Now, that came about based on the review of our test data that brought about concerns with the current 45 height ceiling designs. Some people might ask, well, what concerns do you have? Well, let me kind of go into the factors that can affect full-scale fire test results. The first one we look at is moisture content of corrugated cardboard. So if you have a cardboard box that you're storing stuff in a warehouse, that can be affected by moisture. And it's driven by the relative humidity of the environment. And what that does is affects the heat release rate of the fire. And as you have a higher moisture content, what that does is it results in a slower growing, less challenging fire. Now, we were found out more or less about this when we did some large-scale fire testing using simulated dry systems. So we realized that Mother Nature now was influencing our test results. So back in the late 2000s, FM Global spent a lot of money to upgrade our large burn lab and installed industrial-grade dehumidifiers to condition the lab area. And what that now means is that we have a moisture content that must be within spec or test is not conducted. And with the help of those humidifiers, we can usually keep our moisture content where we need it to be. The other factor that might affect a full-scale fire test is the ignition location. Now we have two different types. The first one I'm going to talk about is the offset ignition location. And if we're doing a rack test, we typically have it at a rack upright. So here's a plan view of a storage array involving rack storage. Now, when I'm referring to an offset ignition location, that's really the location of the fire within the rack itself. It's located in a transverse flue space, basically halfway between the longitudinal flue and the face of the rack. And for rack storage, we put it at a rack upright as well. Non-offset ignition location is similar, except what you're doing now is you're just moving the ignition over to the intersection of the longitudinal and the transverse flue space. Now, what we've found over time is that the offset ignition location is more challenging than a non-offset ignition location, sometimes much more challenging. So what we did for the July 2020 edition of 8-9 is we went back and we looked at every single design in tables 2 through 11. They were reviewed. And those cases where we found designs where moisture content or ignition location were not per today's testing protocol, that certainly raised concerns. And it's not only for ceiling heights greater than 40 feet. So if we go back and look at some of our other tables, such as table 5, if you looked at the 2020 January edition, you'll notice in the July edition, there's some designs in table 5, which is on-floor storage of exposed non-expanded group A plastic. We've removed some designs. And when you look at the designs that are still there for ceiling heights over 30 feet, those were actually increased. And even those for 30-foot high ceilings were looked at, and a lot of them might have been changed. Some designs were increased, some of them actually decreased. Same in tables 7 and 8, which is class 1 through 1, 2, 3, and 4 uncartoned unexpanded plastic or carton non-expanded group A plastic. When you look at some of the designs that were available for the quick response upright sprinklers, those were removed in July. Now, I get a lot of questions that say, well, what if a client was considering a pre-July 2020 design for a 40-foot high ceiling? Well, if we look at the previous designs that were available in, say, table 8, they were basically a K22.4 using 12 sprinklers at 50 psi, or a K25.2 using 12 sprinklers at 50 psi. So if we look at table 17B now, where our 45-foot high ceiling designs would have to go to, if we use the previous design that was available for the K22.4, that required flow is about 2,000 GPM. And now, based on the July 2020 edition, the design is actually less. The pressure is higher, but the flow is less. One thing you have to note, though, that's different is that we have to move the thermal element closer to the ceiling than we had before. That was 17 inches. And now we bring in aisle width. So before you didn't have to worry about aisle width, but now you have to make sure that the client has an aisle width of at least 6 feet or wider. If I look at the K25.2 design, the flow was about 1875 today. So it's still less flow, same pressure. But again, that thermal element has to be a little closer to the ceiling, and we have to look at aisle width. There's another design too for the K25. It's 10 at 75, so it's a higher pressure. The flow is about the same, but the nice thing about this is it does allow the thermal element to stay at the 17 inches that you would have had in table 8, but now you got to bring an aisle width, so that's a minimum of 6 feet wide. So when we look at the major changes, it may not be all that bad. As long as it's okay to install that sprinkler element 13 inches as opposed to 17 inches. And for our open frame racks, we're having a minimum 6 foot wide aisle available for single and double, and actually it will be multiple row racks.
Okay, so that's some, in terms of the fire protection industry and the buildings, these types of buildings that are built out there, I think those changes are significant in that we see these days, and if we go back 20 years ago, for example, storage buildings were typically not as tall as they are today, and we sort of we had a lot of maybe 29, then we went to 32, then up in the upper 30s, and now we see a lot of storage buildings that are built in that, a little less than 45-foot range. So we see that criteria used a lot, and one of the things I think we're gonna, as an industry, have to deal with, and we've had some discussions with some engineers, some contractors about this, is that we'll now see some differences between the criteria in FM Global Data Sheet 8-9 and the criteria in NFPA 13. And in certain locations where you might not have a locally adopted requirement, maybe the designer would just use FM Data Sheet 8-9 and that would be how they do it. And then there might be other locations where the designer is required to apply NFPA 13, where they would end up doing 2 hydraulic calcs, and they would do one to prove out the FM Global Data Sheet 8-9 requirements for essentially insurance purposes at that point, and then they might have to do another one per NFPA 13 with some different parameters to deal with the NFPA 13 requirements that might be a little bit different. I think the reality situation is, Wes sits on the NFPA 13 technical committee. All of the same kind of issues, I think, that you see in the changes in Data Sheet 8-9 are discussed by the 13 technical committee, but sometimes the answer is different. And so from a designer standpoint, I think that's going to end up resulting in maybe a little bit extra work and maybe some different designs that come about because of 2 different standards. And Wes gave a great example of how you deal with a 45-foot building using Data Sheet 8-9. I think what we'll find is if we have to deal with both Data Sheet 8-9 with a 9 and a 10 sprinkler design, a lot of times if you use an NFPA 13 with a 12 sprinkler design, typically on a sprinkler like that, that might be the most demanding going forward. Mm-hmm. So whereas if you look at a Data Sheet 8-9 and select a sprinkler based on that, it might be a different selection once you take into account NFPA 13, because if you end up having to balance the 2 together and make it all work, that could get very interesting. So we'll see how that works itself out in the field. Moving on to other topics here, and quite honestly, let's say I have a design where the owner wants to have a 4 or a 5-foot aisle and they have storage over 40 feet. How are they supposed to deal with that now, Wes, under Data Sheet 8-9?
Okay. Well, to answer that, let's take a look at what some of the differences are between Table 17B and those that are in Tables 2 through 11. Okay, so I think that might help us cover this. When we look at Tables 2 through 11, they apply to open frame rack, so aisle width does not apply. Now, when we go into Table 17B now, it applies to open frame single and double row racks, but now we have to look at an aisle width, okay, and this aisle width is addressed in this table. Now, one of the things I will point out is we, believe it or not, we have another edition of 8-9 coming out next month, tomorrow. It starts October, I believe. So what we're doing is we're actually going to make some changes to allow multiple row racks to be added into this table as well, but it's going to have some limitations as to what that can be for a multiple row rack. So when we look at the differences between tables 17B and those of 2 through 11, we're going to see in some cases, if I have a fire, it can grow. What we have to make sure is for an acceptable fire control or suppression, we don't have any burn through of the adjacent racks. Now, if I bring those racks closer together and I have that same fire, one of the things we're concerned about is the fire jumping across the aisle. So we're finding that for ceiling heights of 40 foot and less, most, our designs actually account for that. Once you get above a 40-foot high ceiling, then the jumping across the aisle becomes an issue. So aisle width now has to be brought back into the equation. And also, when you look at these tables 2 through 11, the location of the sprinkler follows normal installation guidelines. And that means for traditional K14s, K16.8s, they can be as low as 13 inches below the ceiling to their thermal elements, or larger sprinklers have to be have the allowance going all the way down to 17 inches below the ceiling. But now when you look in 17B, a designer is going to have to take into consideration now what the maximum vertical distance is below the ceiling. So now it might vary. And so, for example, there's cases where a K22.4 or a K25.2 that traditionally is at 17 inches now has to be limited to 13 inches. And why is that? Well, when you look at a typical fire, what you have is a vertical distance that thermal element can be located below the ceiling. So when we have that fire take place and the sprinklers operate, the closer that sprinkler is to the ceiling, the more likely it's going to operate in timely fashion and get water onto that fire while the fire is relatively small. But now if I increase that distance to something greater below the ceiling, it takes longer for that heat plume layer to build up under the ceiling, and it allows the fire to get larger. So when the vertical distance increases from 13 to 17 inches, you have a more likelihood that the fire is going to get larger and less likely that the sprinklers might operate in a timely fashion to provide an acceptable level of control. So those are the things that need to be looked at when it comes to for going forward, that the designers have to really take into account to make sure that the designs are properly implemented that are now in 17B.
And so we've talked about the changes to 8-9 related to design number of sprinklers, storage height, some of those sort of things, and how those might apply. One other question on that's come up in the chat a little bit here is now with the 9 and the 10 sprinkler hydraulic designs, how many sprinklers are you required to calculate on each branch line? How is that design area determined?
Very good question. In fact, for the case where you're using table 17B, datasheet 8-9 actually gives you the guidance on that. So if it's a 9 sprinkler design, it's 3 sprinklers per branch line. It's that simple. If you're looking at 10 sprinkler designs, well, then the ceiling slope comes into play. So you would have to take a look and see if my ceiling slope is 5 degrees or less, then you're allowed to do a design based on 3 lines of 3 sprinklers and 1 extra sprinkler on a branch line. But if that slope is greater than 5 and up to 10, then you have to go to 4 sprinklers per branch line. So you'd end up with 2 lines with 4 sprinklers and 1 line with 2 sprinklers. For all the other designs that you find in tables 2 through 11, then there's the traditional formula you use where you take the square root of the demand area size, multiply it by the shade factor, and divide by your online sprinkler spacing to find out how many sprinklers per branch line you need to account for there. One of the things too that's on my list of things to do in the future is actually take the guidance that's currently in datasheet 3-0 that provides that information and move it into 8-9. That way you don't have to go to another datasheet to find out what that number of sprinklers per branch line happens to be.
And that, that's another item that with more 9 and 10 sprinkler designs available, that question will be more common. So it'll be nice when that gets put directly in 8-9, answers it right there. Let's move on to another topic that has some revisions in this update, and that's flue spaces. and particularly flue spaces in multiple row racks, where in the latest update to datasheet 8-9, there's a couple of ways that you can go about providing those flue spaces in multiple row racks, and there's some limitations if you don't provide longitudinal flue spaces in multiple row racks at max 5-foot intervals. Then you may be limited to a 20-foot overall dimension of that multiple row rack per the 8-9 criteria. And
Correct.
And just a little teaser on this, maybe the NFPA 13 technical committees have a ballot in front of them right now for the second draft of the next edition. And there's been a lot of discussion amongst the committees in the last meetings about how to address flue space requirements and multiple row racks. And I think this is one case where the end result of the 13 discussions, we'll see what happens, and what FM has now in datasheet 8-9 are going to look very similar, which I think is great for designers since they're not wrestling with two different sets of requirements. So you can talk about what's happening with 8-9 in terms of multiple row racks and flue spaces.
Certainly. In fact, in 8-9, when it comes to flue spaces, it wasn't only just multiple row racks that we made some modifications to, but I will start with multiple row racks and indicate what those changes are. Now, today, now in 8-9, there's two ways to achieve an open frame rack storage arrangement using a multiple row rack. And that one way would be to provide nominal 6-inch wide vertically aligned longitudinal and transverse flue spaces around each typical pallet, which is call it 5 by 5 foot wide. So if I look at a plan view of a multiple row rack, and we have our pallet loads here in brown, then if these are limited to roughly 5 by 5, then you can consider this an open frame rack as long as we're given 6-inch minimum wide transverse flue spaces around each of these pallet loads that are vertically aligned. Now, I think most people will realize that's not typical of what you see out there in today's world when it comes to multiple row racks. What we tend to see is racks that are pushed together in one direction. So the other way that type of rack, multiple row rack, could be considered open frame is to provide a minimum 6-inch wide vertically aligned transverse flue space that are no more than 5 feet apart horizontally. But you have to limit the rack depth to 20 feet. And then that rack depth of 20 feet is defined by a minimum 8-foot wide aisle. So if I was to show this to you in a kind of a visual way, here again is our plan view of a multiple rack now where we have no longitudinal flues. We're going to make sure that our distance between the transverse flue spaces is no more than 5 feet. The transverse flue spaces themselves have to be a minimum 6-inch wide and vertically aligned, which is usually not a problem. But now we have to limit the rack depth to 20 feet and have minimum 8-foot wide aisles defining that 20-foot wide depth, that 20-foot depth. Somebody might ask, well, where did this come from? Why are we limiting it this? Well, we're actually going to go all the way back to 1971. So when it comes to a multiple row rack test that was conducted, that created the way we provide designs in NFPA 13 and as well as FM Global Datasheet 8-9, it's all based on this test. So back in 1971, what they tested was 6-inch wide transverse flue spaces located roughly 5 feet apart horizontally. In this case, we had 4 pallet loads deep. And now traditionally we assume the pallet loads are nominal 5 feet. So if you take the 4, multiply it by 5 feet, that's where you get your 20 feet. And in the test, we actually used a 10-foot wide aisle. But at this point, we're using some judgment to allow it to be 8 feet. So therefore, our new flue space guidelines represent those that were actually tested. Now, we know that this is going to be an issue. So we're hoping to conduct some in-depth analysis of this storage arrangement in the near future. And when we do, what we'll do is we'll update 8-9 afterwards to incorporate whatever we find. Now, I did mention we've also done some changes to double row racks, and that was really more or less a clarification. So the new guidance in the revised guidance, I should say, clarifies that a minimum 6-inch wide longitudinal flue space is needed when the horizontal distance between transverse flue space is over 4.5 feet wide and up to 9 feet. Now, this kind of probably came into play because FM Global does give you some guidance when there's no longitudinal flue. And what it basically says is you can have something up to about 5 feet wide as long as you provide a minimum 6-inch transverse flue space between those pallet loads. Now, if by chance you turn the pallet load around and store it this way in the rack, now we have a maximum depth of about 9 feet between our transverse flue spaces, and what 8.9 says is you need a minimum 6-inch wide transverse flue space at that point. But what wasn't clear was that this means that you have to have a minimum 6-inch wide longitudinal flue space to keep that, call it shelf area, kind of limited in size. So the new guidelines really clarify that you need to make sure you've got a 6-inch minimum wide longitudinal flue space when your transverse flue space, the distance between them is greater than 5 feet and up to as much as 9 feet. So the flue space guidelines help define when racks without solid shelves can be considered open frame. And when the guidelines for the flue spaces are not satisfied, then our storage arrangement creates a solid shelf rack storage arrangement that typically means they need to be protected as if they have solid shelves. So those are the new guidelines that are currently in 8-9 regarding flues. And as Steve mentioned, they're basically going to match what's in NFPA 13 when it comes to the multiple row rack requirements.
And that still has, a final vote to go in the 13 process. They're still not quite finalized, but everything that we've seen in the first draft and in some of the discussion that's happened with that is that it's heading towards being essentially the same, right? Maybe some minor wording differences, but essentially the same, which is going to, create some challenges in the storage world and storage arrangements. Or the other way to look at it is they'll create some changes in the protection arrangements to accommodate those storage methods, right? Which is the same thing with, having a 6-foot aisle for storage over 40 feet with ceiling only. Well, you can protect more than 40-foot ceiling height areas with aisles less than 6 feet, just not with those ceiling systems.
Right.
Using the engineering. You would typically end up going to an in-rack system for that.
Correct. Yep.
So we'll segue there into in-racks. Datasheet 8-9 and NFPA 13 both have some modern in-rack sprinkler systems now that I tend to call the ESFR in-rack system, even though Datasheet 8-9 doesn't use that term, and the EC in-rack system that are in sections 2366 and 2368. So these new systems are designed to work independently of the ceiling system, which is a little departure from the past where the ceiling and the in-rack systems working together. And I've heard you describe the new in-rack systems before as using a virtual floor concept where they're calculated separately, the in-rack system separately from the ceiling system. Mm-hmm. So that leads to the question that we've received several times, very frequently from customers of, well, how do I figure out my design for my ceiling system, especially if I have one of these new in-rack EC or ESFR in-rack systems at the top of the storage, and I don't really have any or much storage above that. And I think you've got some new clarification in 8-9 that speaks to that maybe you'll talk about.
Yes. Well, let me start with the concept of the virtual floor. Now, I think probably the best way to demonstrate this to our audience is to give an example. So let's say that in this case, I've got an 80-foot high ceiling. And I'm sorry for anybody who works in metric. I don't have the metric values here assigned. And our storage is 75-foot high. And off to the right there, you can see a plan view of this particular layout. The rack depth is 8 feet, and the distance between the rack uprights are 8.25 feet. And our storage tiers are about 5 feet. So in this case, we're going to pretend we've got a commodity that's cartoned non-expanded Group A plastics. And at our ceiling, it could be anything, but let's say it's an FM approved 160-degree rated quick response K25 pendant sprinkler on 10 by 10 spacing. Now, obviously, we don't have any 8 80-foot ceiling only designs yet in 8-9. So this is going to require in-rack sprinklers. So if I start with option 1, let's say per section 2.3.6.8, as Steve mentioned, this one involves a combination of quick response K25.EC to EC pendant storage sprinklers with a horizontal barrier. And you only have to install it in the longitudinal flue for a double row rack. So it's really convenient for those cases where a client doesn't want to install in racks where you might have a mid bay at the face type of in rack arrangement. Now, when it comes to the horizontal spacing, we're putting them basically at the midpoint of each rack bay down the longitudinal flue with our horizontal barrier over top of it. And when you look at the vertical locations that we have, they're located every 30 feet vertically. So in this case, you could put one at the 30-foot level and another one at the 60-foot level. And what happens is every time you put in a level of this type of in-rack protection, it becomes in essence a virtual floor. It's as if now we've instead of having the in-racks there, you put on a concrete floor. And so whatever's left above that is what you can then do to design your ceiling sprinkler to. Because that's the reason for this, because the fire is not expected to get past our in-rack sprinklers vertically. And as a result, the ceiling and the in-racks don't have to be hydraulically balanced together. So the ceiling design can be based on a ceiling height that's above the top in-rack level. So our in-rack design in this case happens to be 4 in-rack sprinklers flowing a minimum of 160 GPM when our aisle width happens to be greater than 4 feet. Now, in this case, we can go and simply design our ceiling as if it's only a 20-foot ceiling in the entire building when those 2 levels are installed. You could also go in and take a look and see, hey, maybe I can get by with 1 level. And so you would install 1 level at the 30-foot level and see if your sprinkler system can protect for 50-foot high ceiling, or if there isn't any sprinkler protection there, you can design it. So it's based on 50 since we have those now available. When it comes to option 2, that's the one that Steve mentioned includes the ESFRs. So in essence, you're looking at a 160-degree nominally rated quick response minimum K14 pendant sprinkler. Now in this case, the in-racks are installed both in the longitudinal flue and at the face for a double row rack. So typically for most commodities that we're trying to protect, you're going to end up with a maximum horizontal spacing of about 4.5 feet. So as you can see in the plan view section there, that's a lot of sprinklers. But depending on the flow you decide to choose, you can either install your in-racks vertically at the 30-foot level. You can get by with a minimum K14 sprinkler, or you can go as high as 40-foot between in-rack levels, but your minimum sprinkler has to be a K22.4. So if you go with 1 level of in-rack sprinklers, say you install it at the 40-foot level, your design would be 6 sprinklers at 120 GPM. And now your ceiling design can be based on a 40-foot ceiling when 1 level is provided. Again, you ignore anything happening below the top level, and you just simply base your ceiling design on what's left above the top. Now, in the event that you decide, you can also put the same type of protection directly over top of the storage. In essence, take the ceiling out of play. If you do that, then 8-9 says you're just simply designing your sprinklers to the surrounding occupancy, if that happens to be a challenge, or the minimum ceiling height that's indicated in 8-9. So it gives you multiple options of how to address protection with racks nowadays that are much different than the designs you were probably used to prior to these designs coming out.
Yeah, so that's some good additional information on that, and I think we'll see, similar systems, not exactly the same requirements, exist in NFPA 13, and I think we've seen, quite honestly, you did some great work in this last revision cycle in taking the 13 requirements and making them a little bit easier to understand and improving those from the current 2019 edition to the 2021 edition and just making them a little bit easier to understand and apply, and doing some of the updates that that we see now in 8-9 on those types of systems. And as things have developed in storage, more automation, more of those kind of things, we see more and more buildings that get beyond the 40, 50, 55 feet that we can protect with ceiling-only sprinklers, and we see a lot of them using a system like you show here on the screen with the virtual floor concept, some bigger K-factor sprinklers in the rack, and really making that more accessible in the storage arrangements. One last item, and then I think we're going to have to turn it over to close this out here based on our time. Anything you want to talk about from upcoming changes to other data sheets or 8-9 before we close it out?
Yeah, I obviously, 8-9 is never seems that we stop testing. So when it comes to potential future revisions to 8-9, one of the biggest things I'm hoping we can address soon is multiple row racks, because we're seeing a lot of the pushback type, the flow through, and because of the shielding effect those have, when they don't have a longitudinal flue, it's now defaulting us to what we have today in 8-9 and soon to have in NPA 13. So I'd like to find out, when we do have those types of racks present, what is it that we need for protection? Because until we know, we're kind of defaulting to, in essence, in racks at every tier level, because it ends up with a solid shelf greater than 64 square feet. We're also doing research in open top containers. And so hopefully once we finish our research on that, we'll have some better guidance to offer how to protect them, and also how to turn them into not being an open top container hazard. Also want to take a look at seeing how we can make it easier for the data sheet to be read and implemented. So we're planning on revising the format to incorporate a lot more figures, maybe some tables, flowcharts, so that we can reduce the amount of text that you have to read through. It makes it easier for the end user to end up in the right spot and make sure they haven't missed anything. And one of the things that we're going to do is, as much as the data sheet's big now, it's going to get bigger because we're going to be incorporating some of our other data sheets that you find typically with a general warehouse, such as idle pallets or horizontal carousels, automatic storage retrieval systems. That's all going to be moved into 8-9 so that it becomes a one-shop place for general warehousing. And when it comes to other data sheets, I'm also involved with 2-0. What we plan to do is update that data sheet next year. And we've done some testing with obstructed ceiling construction. Right now, ESFRs, quick response storage sprinklers, are limited to how far below the ceiling the purlins can be before it becomes obstructed ceiling, and you have to put them in every channel. Our testing will allow for our clients now to install them in deeper channels without needing to put them in every channel. In terms of presence of slope ceilings, we're currently limited to basically a 10-degree on our slope with our ESFR sprinklers. Well, based on testing we've done, we're going to be able to go to greater slope ceilings and provide guidance for what to do there. In terms of obstructions, we've done some testing through the FPRF, and so the results will be incorporated into 2-0 next year. And just like what we're doing with 8-9, we're trying to make it so it's easier to read, more figures, more tables, flowcharts, reduce the text. And that's coming out next year. And one other thing that I'll talk about real quick is automatic storage retrieval systems. There's been a lot of testing we've done with those based on mini loads, top loads. So we're adding new guidance coming out next month for protection of top loading ASRS systems that use non-solid wall containers. Right now, it's currently the scope, that data sheet, only addresses solid wall containers. So we'll have some new guidelines for those types of containers if you come across it. The existing guidelines for mini load systems are being updated to account for use of non-combustible containers. And the same thing goes with top loading when you use non-combustible solid wall containers. And we've reformatted that data sheet so it's clear for the end user to understand what recommendations are based on sprinkler protection and what recommendations are specific to fire extinguishment. Because with those types of systems, automatic storage retrieval, a lot of them make it much more difficult for the fire department to get in to where the fire is. So we want to make sure that the end user knows what it is that's geared specifically for protection and what is there to help the local fire services help put out the fire. And that's coming out next month. Other storage related data sheets, one of the things we're going to be doing is updating those to make them more of the same style that you see in datasheet 8-9. And 8-9 does have the K28 and the K33-6 sprinklers in it, but a lot of the other data sheets don't. So we're going to be updating those data sheets to include those newly approved sprinklers. And again, trying to minimize the amount of text that's provided so it's easier to get through and find what your designs and recommendations might be. And that should cover it.
Thank you very much, Wes. What we're going to do is I'll stay on and answer some more questions in the chat here. We've got a couple more. Thank you very much, Wes, for joining us today. I think the presentation's been very helpful, informative, timely. There's some significant updates in the July 2020 edition 8-9 that, you know, I think those of us who are doing work in storage fire protection should know about. It's good to hear about the things coming in the future. And once again, thank you very much for joining us today. It's been very helpful.
Thank you.